Today I'm going to talk about securing applications with OAuth2 and OpenID Connect using SpringSecurit. I'm Thomas. I work as a senior software engineer at Systematic, a Danish software company. I'm really passionate about anything cloud native. I like working with Spring. I'm even writing a book about it. It's called Cloud Native Spring in Action with Spring Boot and Kubernetes, published by Manning. I also am a big supporter of open source technologies. I like contributing to open source projects whenever I have time, including SpringSecurit and Spring Cloud. The topic for today is security, which is a really broad topic. So let's start to narrow it down and focus on one aspect of security, in particular, application security. I'm going to talk about how to secure applications in a distributed system, so a microservices architecture, for example. And in particular, I'd like to talk about how we can implement an access control mechanism in a distributed system. Access control mechanisms are usually composed of 3 steps. The first step is identification, is when a user claims an identity. In the physical world, for example, I go to a hotel and I say, "Hi, I'm Thomas." In a digital world, I can use maybe a username or an email address. But that's not enough. We have the authentication step, so we need to verify the claimed identity. At the hotel, I would be asked for an ID, for example, my passport or a driving license. In the digital world, we can use passwords, tokens, certificates, even a combination of different factors in order to have stronger authentication. And then finally, once we know who we are dealing with, who is the user, and we are sure that the user is exactly who they claim to be, then we can move on to authorization. So verify what the user is allowed to do. In a hotel, if I have a room reservation, then I'm only authorized to access my own room. In the digital world, we talk about user roles, user permissions. So we can only do a limited number of actions on a system, depending on which permissions we've been granted. We want to implement access control mechanisms in a distributed system. And in particular, the example we're going to look at today is an example of a bookshop system. So we have some users that access the system through an edge service, which is basically an API gateway. Through this gateway, we get access to several microservices dealing with different aspects of a bookshop system, for example, for managing books, for managing the inventory, and for managing orders. So before discussing how we can secure this system, let's have a look at the existing version of the system where we have no security. So we familiarize with the basic functionality. So I'll move on to IntelliJ now, where I have my application already implemented. We're going to focus on BookService and Edge service, but all the things I'm going to mention today, they will be valid with any number of backend applications that we might have behind the gateway. BookService is a simple Spring Boot application. We have the main method where we initialize the Spring Boot application, and then we have a record in order to model the book entity with 2 fields, ISBN and title. ISBN is to identify uniquely a book. And then we have a REST controller exposing some functionality regarding books. For simplicity, I'm using an in-memory storage. So I have a map with some books. And then we have functionality in order to retrieve books, either all of them or based on an ISBN. And then a method in order to create new books. So we support this GET and POST request through a RESTful API. The application is exposed through port 8000, but it's in the backend. It's not used directly by clients and by users. It's accessed through a gateway, which is Edge service. So if we have a look at Edge service, it's another Spring Boot application, but in order to have the gateway functionality, I'm using the Spring Cloud Gateway project. So in the application property file, you can see that the gateway is exposed through port 9000, and I have defined a route. So it means that every time I send request to the gateway, which is the entry point to the system with the path starting with /books, then those requests will be forwarded to my book service running locally on localhost port 8000. This is the basic gateway functionality. Then if we look at the Java code, I have implemented a small endpoint to return a welcome message. And besides that, we have the main method in order to initialize the Spring Boot application. So now I will start both applications. We have no security whatsoever, so no authentication, no authorization. So we can see how the system works before we start see a few options in order to make it more secure. So we have the book service started. Let's start the Edge service as well. And let's refresh the Gradle dependency and refresh the application. All right. Yes, let's give it a second. There's a caching problem. All right, almost done. Yes. So let's restart book service and Edge service. Once again, yes. And then to send a request, I'm going to use a utility called HTTP. So I can send an HTTP request to port 9000, which is the port exposed by Edge service, and then /books. Since the path starts with /books, then the request is forwarded to book service. So let's see how it works. So we are getting back a list of books. This is the foundation of the work we're going to do today. So now that we have the basic functionality, let's start looking at how we can secure these two applications. Now, in when we talk about Spring Boot applications, the de facto standard for securing applications is SpringSecurit. And SpringSecurit is a great framework which provides support in three main areas. The first is authentication, provides support for different authentication strategy through a uniform API. So we can support username and password authentication, or OIDC and OAuth2, the one we're going to use today, SAML2, and more. Also, it will provide support for implementing authorization policies at the endpoint level when we have web applications, but also at method level and at object level. And finally, it also provides protection against the common attacks like session fixation, CSRF, and content injection. And the great thing is that the philosophy of SpringSecurit is that an application should be secured by default. So a lot of these protections are enabled by default, which is really great. Then on top of all the default configuration, we can customize and provide some extra configuration in order to tailor the configuration to our needs. So if we consider our system, we want to start with authentication. Authentication meaning that we want to know who the user is, and we want to verify who the user is. So to ensure that it's actually who they claim to be. So if we look again at the system, we have a distributed system, and the entry point is Edge service. So besides being an API gateway, it's actually a very good place to implement some cross-cutting concerns like security. It's the ingress point to the system. So it makes sense to have this application also takes care of authenticating the user. But if we start implementing a lot of security features inside Edge service, then we would mix up two different concerns. And in particular, security is a really critical aspect of any system. So it really makes sense to move it to a dedicated service so that we decouple Edge service and this dedicated service, we can call it Auth service. And what happens is that Edge service is still responsible for initiating the user authentication flow whenever a request is not authenticated. But then it delegates the actual authentication step to a dedicated service. So we have them decoupled. And when we do this, we need to consider a few aspects, a few requirements that we might have in our system. So first of all, the authentication strategy. I named some of them earlier. So do we want to have username and password-based authentication? Do we want some social login, maybe login with Google, login with GitHub, or maybe the bookshop employees are already registered in an Active Directory instance. So maybe users want to have single sign-on and rely on that same system to authenticate. So we need to discuss which strategy do we want. And we would like to have support for different strategies without disrupting the entire system. So having all these changes whenever we want a new strategy basically limited within the authorization and authentication service. Next, we need to establish a protocol. Edge service needs to delegate the authentication step to this dedicated service, and it needs to do it according to a specific communication channel and protocol. And in particular, we would like for this protocol to be uniform. So independently from which is the authentication strategy used, we want to have the same protocol so that whenever we change authentication strategies, we don't have to change edge service. So we have two loosely coupled services. And finally, once the authentication step is completed, then edge service needs to know who is the identity of the user who just authenticated. So auth service needs to provide, using some data format, information about the authentication event. One solution that is really popular to solve all these problems is OpenID Connect. OpenID Connect is a protocol which is built on top of the OAuth2 framework that enables an application that we call a client to delegate the authentication step to another party, a trusted party that we call authorization server, so that the authorization server takes care of authenticating the user, and then the client trusts the authentication step performed by the authorization server and retrieves some information about the event. So if we look more at our architecture, edge service will be our OAuth2 client. So if we reason in terms of the terminology in OAuth2. And instead, for the authorization server, we can use a lot of different services. In this particular example, I'm going to use Keycloak, which is an open source identity and access management solution. But you can switch it, since we are using a standard protocol, you can switch it with other services. So you can use for example, Okta, you can use the Spring authorization server, you can use Auth0, you can use Twitter, you can use Google. At that point, it doesn't matter because we are relying on a standard protocol. So the focus for implementing authentication will be on edge service and Keycloak. So let's have a look at the code and how we can implement this first part of our access control system. So I'll go back to my code, and we go into edge service. And the first thing I need to do here is adding a dependency on SpringSecurit with configuration for an OAuth2 client. And Spring Boot provides a starter dependency for that. The Spring Boot starter OAuth2 client dependency. So I'll uncomment this dependency here, refresh the Gradle dependencies. And then I can start integrating the application with Keycloak. But first, I need to register edge service into Keycloak so that Keycloak knows that edge service is actually an authorized component to be served in terms of authentication and authorization. I have a Keycloak container running locally. We can have a look. So I have defined the Polar Bookshop realm. A realm in Keycloak is the context where we define different security policies for a specific use case. So I have a Polar Bookshop realm, and in here I have configured a client. So I'm being logged out, so log in again, perfect. So I have registered edge service as a client. The client ID is edge service. I configure it to use OpenID Connect as the protocol to be used for this delegated authentication step. And the client type is confidential, means that we want edge service to authenticate with Keycloak as well. And we do that via a shared secret. In this case, the secret is Polar Keycloak secret, which is really not secret at all. But that's what we're going to use. Also, in Keycloak, we also have a couple of users that we're going to use for testing the security of the system. They are Bjorn and Isabel. So we can use them to access the system and verify that all the changes we're going to do to secure both applications work correctly. So at this point, I go back to Edge Service. And in the application properties file for Edge Service, I need to configure the integration with Keycloak. So I'll add a new section here. For an OAuth2 client. And first I need to specify the registration details that I have configured in Keycloak. So we have the Keycloak provider, and we have a client ID, which is Edge service, the client secret, which is Polar Keycloak secret. And then we also define a scope. Now, a scope, OpenID, means that on top of OAuth2, I want to be able to use KeyCloak also for the OpenID authentication flow. So by using this scope, I enable the authentication flow based on OpenID, and also I ensure that Edge service gets access to the user information after the authentication event completed successfully. And then the last thing I need to do is configuring how to talk with KeyCloak. So I need to define an issuer URI. I have it running on my machine, so it will be localhost 8080. And then I need to specify the URL for the real that I want to use, which is Polar Bookshop. And this is it. This is how we integrate with KeyCloak. And the same configuration applies whatever basically OpenID and OAuth2 provider we use. So there's nothing specific to KeyCloak. I can switch service and change the URL to point to the other service, and it will work. It's a great thing when we use standards like OpenID Connect and OAuth2. Next, I go to the Java part of the application, and I want to configure the application. I want to define some security policies so that all endpoints exposed by the application are protected. And I can do that by defining a bean of type security web filter chain. This is exactly a way to define a chain of filters that are executed whenever a request arrives to the application. And it's how we intercept the request and perform some processing before actually processing the request itself. So to check, for example, for authentication, authorization, and other security aspects. So let's define this bean. We can build it by using a convenient and fluent API provided by an object called server HTTP security. And then I can use that object to first, I want to make sure that all requests requires authentication. Edge service is a reactive application, so when we work with the reactive stack in Spring, we call a request exchanges. So we have an exchange here, and we want to make sure that any exchange, so any request, is authenticated. So if it's not, then the request is denied and the user is prompted to authenticate. And then I need to specify how I want the user to authenticate. I have different strategies supported by SpringSecurit. In this case, I want to use OAuth2 with the login functionality extension that is provided by OpenID on top of OAuth2. And I'm fine with the default configuration. And then I build the object. Perfect. So now we have the integration with KeyCloak done. We are protecting all the endpoints. So now they require authentication. So let's restart the application and see how it changes now. This same approach in SpringSecurit can be used independently from the strategy. So instead of having the OAuth2 login strategy, you could add, for example, support for a login form or for a HTTP basic authentication or for other strategies. So it's a really convenient programming model that is really coherent independently from the specific strategy that we want to use. And now that the application is running, I'll move on to the browser. Let's open a private window and go to localhost 9000. Let's see if the welcome message works fine or if we are correctly prompting for an authentication step. And we are. So we can see that SpringSecurit automatically redirected us to Keycloak, which is running on localhost 8080. And Keycloak is providing this username and password form. I can log in with Isabel, one of the users in the system. And then I'm redirected back to Edge service. You can see localhost 9000. And I get the message back that I have originally requested. So we have at least a basic version of authentication, of user authentication implemented in the system. What is happening behind the scenes is that the user calls Edge service. Since we are not authenticated, we are redirected to Keycloak. So the user actually performs authentication directly with Keycloak, which means that no credentials are exposed to Edge service, which is really great. Once the authentication is done, then Keycloak issues an ID token. An ID token is an object, is a data structure which follows the JWT format, JSON Web Token, in order to send some information to Edge service regarding the identity of the user that just authenticated. So it can contain information like the issuer, that in this case is Keycloak, the username, we have Isabel as the subject of the ID token, and we have, for example, the expiration date. So when this ID token stops being valid. So with OpenID, OpenID Connect, we solved those problems that I mentioned earlier. So we have a way to delegate authentication to Keycloak, a dedicated service using the OpenID Connect protocol. We have the ID token as the data format in order to exchange information about the identity of the user. And since now we have these two decoupled services, Keycloak is free to authenticate the user independently from what Edge service is doing, because right now I have used a username and password form, but I could configure Keycloak in order to integrate with an Active Directory or to support two-factor authentication, or maybe to log in with Google or Apple. And by doing all of that, Edge service doesn't need to know, doesn't need to be changed, because we use OpenID Connect as the single protocol for handling authentication, which is really, really great. Now we have a problem. We focused on Edge service and Keycloak. The user is authenticated, but Edge service is a gateway, right? So we have a bunch of microservices in the backend that are the ones that contain resources that are protected and that the user is interested in accessing. For example, a user wants to get a list of books. So how can we secure BookService so that also all the endpoints in BookService are protected and somehow propagate the user context from Edge service to BookService? When we address this problem, we talk about delegated access, because Edge service takes care of the authentication through OpenID Connect, but then we need to delegate Edge service to access BookService on behalf of the user. So if we look more closely, we are focusing now on the communication between Edge service and any of the other microservices in the backend, for example, BookService. So we need to solve the problem of security context propagation. So Edge service knows the identity of the authenticated user. How can we let BookService know as well? And then how can we ensure that Edge service gets authorized access to BookService? And the answer to this is OAuth2. OAuth2 is an authorization framework that enables an application called a client to obtain limited access to a protected resource provided by another application that we call resource server. And it does that on behalf of the user. So the user authenticates with the client, and then the client accesses a resource server on behalf of the user. So in our example, we have Edge service, which is the client, and BookService, which is resource server. So I started talking about OpenID Connect first because authorization always happens after authentication, even if OAuth2 is the foundation on which OpenID Connect is based. But OAuth2 handles only authorization. That's why we had to first deal with OpenID Connect. Once the user is authenticated and we have a security context in place, then we can start talking about delegated access and how to get authorized access from Edge service to BookService. We have a solution also in this case, and this is the access token. An access token, once again, is provided by Keycloak after a user is successfully authenticated, but this time the access token is used by Edge service in order to get authorized access to BookService, to an OAuth2 resource server. So the ID token is only meant to be used by Edge service, and it informs the application about the identity of the user. But then it's the access token that is required to get authorized access to BookService, and it's done on behalf of the user. So you can see inside the token, we have the subject, which is Isabel. So Edge service is accessing BookService on behalf of Isabel. And the original use case for OAuth2 was actually when a client and resource server were on two different systems. For example, think about an application that lets you schedule and post tweets on your Twitter account. We don't want to share with this third-party application our credentials for Twitter. Instead, we can use OAuth2 in order to provide them with an access token with limited access so that they can post on Twitter via that access token without us having to expose our credentials. So that was the original case for OAuth2, but we can translate it to a distributed system where both the client and the resource server are in the same system. But the idea is that we don't share credentials. We have an access token, which is limited in time, so it's valid for only a few minutes, and it provides access, specific access, only to a specific functionality of the system. So at this point, let's move to the code and see how we can extend what we have done so far in order to also have this security context propagation based on the access token. So we should start with BookService. So BookService right now is not secure. So we need to add SpringSecurit also to BookService. And since in the OAuth2 scenario, BookService plays the role of an OAuth2 resource server, I can use the Spring Boot Starter for OAuth2 resource servers, still based on SpringSecurit. And let me refresh the dependencies. Perfect. So now, the first thing I want to do is configure the integration with Keycloak. So in the properties file, I can use the SpringSecurit properties. We have the resource server, and the issuer URI is the same we used in the other application, localhost 8080, and then the realms, which is Polar Bookshop. But this time we have to specify the format for the access token. Now, unlike OpenID Connect, where the standard itself defines the ID token as a JWT, OAuth2 is a framework that doesn't enforce a format for the access token. It can be any string. A popular format is JWT, but we have to be clear about which format we decide to use. So we're going to use access token as JSON Web Tokens. And next, in a very similar way as we did earlier in Edge service, we want to protect all the endpoints of BookService so that they require authentication. So I'm going to create a new bin here, security filter chain. We can use the Fluent API provided by Http://security. BookService is an imperative application, so the syntax is slightly different. So we have request instead of exchanges. So we can say request, and then request, any request authenticated. So now all endpoints requires authentication, and we want to configure the authentication to be based on OAuth2 resource server. It means that a request requires a valid access token in order to be processed. And once again, we have to be specific about the format we want to use. And we want JWT. Perfect. Let's add the exception handling, and we are good to go. Now, I want to show you the differences between the imperative syntax and the reactive syntax. They are really similar, so I'll keep the imperative syntax down here, and we can compare it with the reactive one. So you can see that it's the same approach. We have slightly different interfaces. For example, in the imperative application, we have HTTP security, while in Spring Reactive, we have server HTTP security. And then the filter chain also has a different interface: security web filter chain and security filter chain. But besides that, the programming model is the same, which is really convenient when we are moving between imperative and reactive applications. We don't have to learn anything new. It's the same approach for configuring these security policies when we use SpringSecurit. All right. So we have a secured book service. So it will require now a valid access token. This access token is digitally signed. So that's why we need the URL for Keycloak, so that whenever we receive an access token, we can validate the signature on the access token by using a public key provided by Keycloak. Yeah. And then the last step is ensuring that Edge service actually provides this access token whenever it sends a request downstream to BookService. Since I'm using Spring Cloud Gateway, that's quite easy. So if you remember, we have a route where we configure how we send a request to BookService. And I can configure this route so that before sending the request, I add a filter for token relay, meaning that it's a built-in filter which will get the access token for the currently authenticated user and put it in the request as an HTTP header before sending the request to BookService. We also need a second filter called save session, because in Edge service, we need to keep a session in order to map the authenticated context that we have with the user browser and the access tokens that we need to send down to BookService. So I'll say something more about this in a second, but first let's verify that it actually works correctly. So I will start both the applications again. So I start BookService, which now requires an access token. And I'll start Edge service as well. So we can validate that BookService is now fully protected by sending a request to port 8000, where BookService is exposed. So if I say /books directly on BookService, I should get an error. And indeed, I get a 401 unauthorized error, which means that I haven't provided an access token, so the request is refused. So now that we have both the applications running with this new update, we can go back to Firefox. So let me first remove all the existing sessions. So we start clear, and then we go to localhost 9000/books. We are required to authenticate, of course. So let's log in as Isabel, and then we get back the books. So a lot of the important things here happen behind the scenes, under the hood, because SpringSecurit provides full support for OAuth2 and OpenID Connect. So what happened is that the user authenticates with Keycloak, then Keycloak sends an ID token and access token to Edge service, and Edge service uses that access token to forward the books, the /books request down to BookService. BookService validates the access token and returns the list of books in the catalog. So I mentioned sessions earlier, so I want to say something more about that. Yeah, so Edge service is responsible for keeping a map between a session and access token. Between browser and Edge service, once the authentication is completed, we use a communication based on a traditional session cookie. But then between Edge service and all the services downstream, we need an access token sent at every request. So we have a stateless communication between Edge service and all the resource servers. But between Edge service and the browser, we need a session in place. So Edge service needs to keep this map between session and access token. So that's why I also use that filter in Spring Cloud Gateway to be sure that we save the session before sending a request downstream to BookService. So we are in a very good place now, but still we are missing something, because this approach right now works fine if we have applications exposing a front end which is server rendered. So for example, if we use Thymeleaf, then we would be almost done with the whole access control setup. But it's very popular nowadays to actually use a single page application, so a separate application built with Angular or React or Vue.js. And when we do that, we need to take care of some few extra security configurations when we integrate this front end with a system like we have right now, where we implement security based on OpenID Connect, OAuth2, and SpringSecurit. So at this point, we're gonna introduce an SPA frontend in our infrastructure and see which changes we need to apply to SpringSecurit. I'll go back to the code. And I have already an Angular application. It's called UI application in here. I want to have Edge service actually serving this application to the browser as static resources. So in the build Gradle configuration for Edge service, I need to instruct the process to include all the static resources coming from Angular. So I have built the Angular application. I have generated all the static resources required in production. So I copy all those resources into a static folder inside my Spring Boot application. So we can start by verifying that that is true. So I stop and rerun Edge service. And now as part of the build, I will also get all the Angular static resources included in the application. So we can double check that that is true by checking the build folder for Edge service. And in resources static, we have the files generated by Angular. So let's go back to the browser. Let me clear the sessions one more time and see what we get now. So let's go to port 9000. This time I'll just want to access the root endpoint, which is where the Angular application is served. And of course, I'm not authenticated. So once again, I'm redirected to Keycloak. Let's log in with Bjorn this time. And now I'm back to the application. So I can, for example, browse books. So I can see the books. I can log out, and I can even add new books. Or maybe I can't. Let's give it a try. So let's add The Lord of the Rings. Let me also open the network tab and let's see what happens. Nope, 403. I'm not authorized to create a book. So what is happening behind the scenes is related to the type of request that I'm sending. So if you noticed, I got the book, all the books in the catalog without problems. That was a GET request. But now I have a POST request, which is failing. But let's give a try to the logout functionality, which is also a POST request. SpringSecurit by default exposes a /logout endpoint that you can call by sending a POST request. Let's see. Oops. An expected CSRF token cannot be found. So that is actually the reason why we're getting these errors. SpringSecurit is secured by default. One of the protections that are enabled by default against common exploits is the protection against cross-site request forgery, in short, CSRF. And this affects all mutating requests, so post request, put request, and delete request. The CSRF approach used by SpringSecurit is based on a token that is sent to the client via an HTTP header. And then the client is supposed to send it back as an HTTP header. SpringSecurit will check it and ensure that there's no cross-site request forgery. But when we use Angular, Angular doesn't support reading the CSRF token from a header. It expects to find it as a cookie. And SpringSecurit has a solution for that. So if we go back to the code, in particular to the Java configuration, we can make that work. So in the security filter chain, I can further configure a CSRF so that we use the CSRF token repository, which is not based on HTTP header, but it's using the cookie implementation. And this is specifically for Angular. So even if we check the comment for this class, we can see that it follows the conventions of Angular.js and now also of the new Angular. So in an imperative application, this would be enough, just defining this different approach for handling CSRF tokens. But when we deal with reactive applications, we need some extra configuration in order to ensure that the CSRF tokens are handled correctly. So I won't say too much about this. I think that it's something that is needed now, but there's an issue in GitHub, so probably will be fixed soon so that you don't need to add this filter, but basically it's because of how the reactive approach works. It means that we have some CSRF token, but until we subscribe to it, then it's not actually returned. So it's a workaround to have this work also on reactive applications. In imperative applications, instead, it would be enough just defining the CSRF token repository. But now that we have this in place, I'll restart the application. Let me close this one. And in a minute, I'll also explain why I keep going to Keycloak and log out all the user forcefully. We'll get there in a second. So I'll start a new window, localhost 9000, once again, root endpoint. I want to get to the Angular application. Let's log in. Now I get the application. I can see the books. It was working also before, but now let's see if I can create books. So if I'm allowed to send a post request. So let's see if this time I can add the Lord of the Rings to the catalog. And this time it works. So we can see that it's now added to the catalog. That was because of the protection against cross-site request forgery. So be aware that if you're working with a single page application, then you need this extra configuration to make it work. The next thing I'd like to mention is that probably it's not ideal having this automatic redirect to Keycloak. When we have a single page applications, probably I want the application itself to be in charge of initiating the authentication flow via some login button, right? So in the spirit of having a proper REST API, I don't want Edge service, in particular SpringSecurit, to return a redirect response. So an HTTP 302 response. I want to return a 401 response, and then let Angular decide when to start the authentication flow. So going back to the code, I can disable the automatic refresh, which is perfect if you're working with Thymeleaf and other server-rendered pages, but for SPS it's not ideal. So we can add an exception handling specification here and make sure that whenever we send a request which is not authenticated, then we want to send back a 401 response. So I can do that with HTTP status server entry point and defining HTTP status unauthorized. So now if I access the application and I'm not authenticated, I get back a 401. I need to pay attention here because since now I don't get the automatic refresh, I can't even access the Angular application, so I have no way to initiate the login. So instead of having all the requests authenticated, I need to at least allow unauthenticated access to the Angular page. So I have to add here that whenever we have the root page where Angular is served, but also CSS and /JS file. I missed some dots here. Then this request should be permitted. So if I do this and restart the application, once again, log out all, and then go back to localhost 9000. Oh, the application is not up yet. Okay, now it's up. Perfect. So now we got to the application without being logged in, right? So I have the login button, and I can decide when I want to log in. So if I click the button, then it starts the whole OpenID Connect flow for authenticating the user. So I can log in, and I have access to all the functionality as before. But this is a better approach when we deal with SPAs, because the automatic refresh is problematic because of CORS issues. So when we send an HTTP AJAX request, so not from the browser, but from the Angular HTTP client, if we get back a redirect to a service with a different origin, like it would be KeyCloak, then the browser would deny the request. So it's not only a nice to have, but it's actually something that we need to have in order to make the whole flow work, because we have two separate applications. So just something to consider. Now, the last thing that we haven't still addressed is the logout feature. So you notice that I keep going to the KeyCloak administration page and logging out all the users. And the reasons for that is that if I click on logout, I'm actually logged out from the Spring application, but I'm not logged out of KeyCloak. So I need a way in order to propagate the logout request from Spring to KeyCloak. And we are lucky because the OpenID Connect protocol has also a standard defining how we can propagate this logout from the application to KeyCloak. And SpringSecurit provides support for that, of course. So we can define here OADC logout. Yes, so we have a logout success handler. It means that it's an object that we can use to define what to do after a logout operation has been successfully completed in Spring. So by using this handler, after we logged out of Spring, we also send the logout request to KeyCloak. Then KeyCloak will log out the user from KeyCloak as well. And at the end, we are redirected. So we have this post-logout redirect URI. We are redirected to the base URL of our application, which is the homepage. So the last thing I need to do is actually using that handler. So I'll add a new security policy in the filter chain. So we want a logout success handler like this. And we need to provide this object. We can auto-wire it. This is auto-configured for us. So I can inject it here and pass it to the method like that. So once again, I have configured the logout operation so that when it's executed successfully, we also forward the logout request to KeyCloak. This is called client-initiated server logout. So the logout is initiated by the application, the client, in our case is Edge service, and then is forwarded also to KeyCloak. So let's start the application for one more time. So from this point on, now I can forget about KeyCloak, right? Because every time I log out, I'm logged out both in Spring and in KeyCloak. So let's go to localhost 9000. I can log in. And let's see, now I'm gonna go ahead and log out. So I'm redirected to the page. I don't even see the back channel request sent to KeyCloak, but I can verify that I'm logged out of KeyCloak because if I click on login again, then I see again the form login, meaning that there's no more active session in KeyCloak. Now for the last part, so we haven't really talked about authorization because user authorization in terms of roles and permissions, because it's not really, there's no single way of dealing with this. So we're using OAuth2 and OpenID. There are some ways that you can do that. For example, you can use scopes, or you can use some custom claims inside the ID token and access tokens. If you're more interested in learning about that, I have a GitHub repository with some examples regarding SpringSecurit. And in particular, you find examples on how to extract user roles and permissions from both ID token and access tokens in both imperative and reactive applications. Having said that, I really thank you very much for joining this session. I hope you enjoyed it. All the source code, you can find it on GitHub. You can also see how I have tested these applications using integration tests based on the SpringSecurit test utilities and also test containers. And you can find some extra examples about SpringSecurit. Thank you very much.
Thank you, Thomas, for your talk. I think many people could have a question, so please join the discussion table on Rocket platform to talk to our participants. Thank you once again.
Thank you. Bye.